Hello, everyone, and welcome to today's webinar. My name is Philip Radukic, and I'm a product manager and senior consultant here at the Experts, and as such responsible for the UPV web services, browser-based viewing, and associated technologies. Well, today we're continuing a new webinar series where we concentrate on various real-life use cases, and these use cases will show some examples on how the UPV ecosystem can be implemented to make processes in your company run more smoothly, how to save time and effort, and utilize the various features of UPV at its best. Today's part 5 of the series will be covering a topic basically relevant to any existing asset, be it for owners and operators or for engineering partners and contractors, and that's turnaround management. As always, the session will be recorded, and we will provide you the link to the recording subsequently by email. At any time during the webinar, feel free to use the questions panel and state your questions, and I will try to answer as many as possible after the live demo we're going to have today. Now, let's have a look at today's agenda. So we'll have a look at the challenges in turnaround management and a live demo covering the challenge checking space requirements and assessing the situation on site. We'll look at the challenge of tracking progress during the turnaround. We'll take a look at running animated simulations and also visualization of schedules. What this means, I'll come back to that a bit later. And well, what's actually the big thing about, or what's the big challenges in turnaround management? During turnarounds, there's a constant flow of changes and challenges. So we're talking about coordination, progress tracking, tight schedules, and many more. And every company has its own workflows, how to handle these challenges, which in return require a lot of time for preparation and planning far ahead of a turnaround. From my own experience in engineering before I joined the Experts, I know that some projects actually took years of preparation for turnaround and raising a lot of questions. For example, is there enough space for the crane to be positioned as planned? Can the crane maneuver in the space given? Can the crane loads be moved accordingly? Is there enough space for a laydown area for the equipment or for scaffoldings? Can it perform certain tasks during the turnaround in parallel, or is this restricted due to other works being conducted influencing the time frame or due to safety issues? And these and more challenges is actually what we're going to look at today. So check your space requirements. What are the risks? Insufficient information, sometimes perhaps complicated calculations of space, delays, because basically spaces have been planned multiple times, lack of communication, and so on. Tracking progress. Mostly it's actually a lack of visualization, where planning errors are evident sometimes too late to really react to them. Running simulations. Well, to be honest, most of the time we're lacking, or you're lacking the coding tools for it, or these tools are just too expensive, or just implementing this in a turnaround is too expensive in the sense of time it takes. So that's something you might as well skip. And visualization of schedules. So do we have any activities colliding? Is perhaps a replanning required? We're risking delays. And colliding activities, I'm going to show you an example later on in the live demo where we can really see what the problem could be. So our solution is, first of all, you can place objects in space holders directly. The effect is reserved spaces are visible and easy to handle, and especially they're visible to the whole team. Track the progress by construction stage. Visualize stages are on schedule and steer accordingly. So you can see in your digital twin what the status should be and what it is, and there's different ways of actually visualizing and holding those stages against each other. Easy animations of any object in the plant. This actually gives us the option to visualize motion procedures, view at them from any angle, and also for this we will see a live demo. And identify assignment overlaps and risks. Save time and cost in the planning phase, avoid risks during construction, and be able to prepare everything efficiently and save basically time and cost in advance before even the turnaround starts. Good. I think we can start the live demo now. And I will start with our default demo plant and checking space requirements. So what could we check space requirements for? We could, for example, use sketching to set some off-limit spaces. So let me actually delete this sketch here and create a new one. For example, by placing a box here, spreading it out easily with the sketching functionality, moving it up here. So now I can colorize it red, make it transparent, and just give it the name reserved 01. And with a few clicks, I've already set a reserved space that we shouldn't intrude. So if I'm checking my further space requirements, let me pick, for example, train from the catalog. So I'm already in the crane section, that's good. And let me see, yes. I didn't want to place a too big one, and let me now rotate it to face us. Move it over a bit. And first of all, I can not only set space requirements for the crane itself. So let me place it equal to this level here. So now I can already see, okay, shouldn't place it in this reserved space. Move it back, and it fits. What else can we do? Since this crane is actually made with the 3D symbol designer, there's also some details that we can actually adapt here. For example, these stamps here for the stabilization of the crane during the works. And now we see, okay, these base requirements are met. So we can work with this easily. I could also say place a scaffolding here. Basically, it would be the same thing. Go to the catalog, structural scaffolding, place it here, rotate it, and since again it's a parametric symbol, I can just pull it to the width and height I need it, staying well outside the reserved area, and seeing, okay, does this fit? Can we do this, or do I have to move the scaffolding away a little bit? So again, another space requirement that we have made sure are met just within UPV and the model we have. This works as well with laser scans, especially we talk about turnarounds and existing plants, as well as 3D modeled surroundings. So I can now also place a scaffolding, let's say here, inside the laser scan area, and make sure I'm not colliding anywhere and that I have enough space to work around, to work with. So, but once we start our turnaround, once we actually begin to work, the next challenge is actually, well, how do we track the progress? And also with UPV, we have several ways to actually achieve this. One thing is, for example, using basically a 4D system where we have planned the progress. So down here we now see a timeline starting Monday, March 2nd, 2020. And now I could actually say, okay, I want to move 12 hours per second. So in this part of the plant, you see everything is gray out. This means this is planned but not built yet. And while I start this animation, whenever something turns dark blue, it's currently under construction at this point of time. So let me actually take some reasonable time. Okay, Friday, March 6th at 11:40. Okay, these guys are working on night time. While it's dark blue, this means it's under construction, and once it's finished, it basically takes its final color. And this way, we can actually see, okay, at this point in time, this all should already be there, and this small platform here should be under construction at this moment. So this way, we can already track progress quite easy. So how else could we track progress? We can integrate pictures taken, for example, from mobile devices or from a camera and integrate them in the existing model. What does this look like? Well, let me close the animation and show you an image I've prepared here. Perhaps have our stack here only viewed in 3D and say, okay, I have an image here. A picture I've taken, in this case, it was, for example, taken by drone. And now I can basically use the slider to switch between the image and the 3D model, or even have them overlapping. That way, I can also compare progress if the image fits what's actually supposed to be done at this stage and this point of time. And it also gives us the opportunity, especially when we talk about turnarounds, to use some analytical images to actually have a look at, we turn on the UAV view, and then go into the thermal image here. What we can also use thermal imaging, overlaying over laser scans or even 3D models to show us the state of the object at hand. So, what other use cases do we have? Well, we want to run simulations. So, what I did before, the reserved space of the crane, that's already been helpful. But let's say I really want to see, does this crane have enough space to move around? And do my objects collide in any way? So for this, we also have a small demo prepared. Oh, no, that was the wrong one. Here we go. So the crane needs to move in here, pick up this vessel, this drum, and place it over here on a black laydown area. I'll run this double speed. So not only that we're able to do animations and simulate single scenarios in UPV, but further than that, this is not a video we're watching at or we're looking at, but it's basically a scenario I just rewound a bit that we can view from any angle while it's running. So it's a real-time animation that we can really analyze from every angle and make sure that everything should work as planned prior to even starting any physical preparations for the turnaround. Thus giving us more safety, giving us a certain efficiency in making sure that everything is running exactly as it should be once time comes for the turnaround. But okay, honestly speaking, there's been plenty of space here. But I have prepared actually a different scenario in a different plant. And that's, we actually want to remove this heat exchanger here, which is pretty much in the middle of everything. And we want to lay it down here. So we need to find some space for a crane to fit and to fit in a stable way. Well, I would say mission accomplished. By using UPV and placing the crane, we actually found a spot here where the crane can exactly be placed without any issues and move around freely, collision free. So how will we now actually use the laydown area? Here, let me actually load a sequence and start from scratch. First of all, the pipelines here need to be removed. So let me hit the play button here, which we realized by fading them out. Then pulling our heat exchanger, moving it over, and even here, while we're concentrating on the heat exchanger, let's also have a look at the crane. Also, we're not colliding with any structures here, and have plenty of space to lay the heat exchanger down to, for example, be picked up by a truck or similar. Well, but this is one of the usages of the animation features, animation sketching features. Basically, what about visualizing schedules? Okay, I know you would say I've actually shown this with the progress tracking. There's yet another option here, so we can set certain flags to certain scenarios and to certain timestamps. So let me close the sketch again, and let's actually have a look at our work order planning here, especially around this rack here. Let's open up a work order planning and hide my info bar. Where you now see we have certain like text here. I want to click on them. A text appears coming from our 4D planning tool whatsoever. In this case, it says, okay, welding start. Up here, this is actually looking good. And it stays like that up to the point where you say, okay, installation starts. That's what I mentioned at the beginning of our webinar. That's something you can plan in your 4D planning system easily, and you would never assume having any type of conflict here. But when we visualize it, we actually see, hey, there's still someone up here doing some welding works. So there's no way we're going to be able to work safely underneath the welding spot and start some installation jobs, especially if the installation was actually supposed to stop here and the welding is still going on up until this point in time. So this way, the visualization actually helps us find some risk or hotspots that we wouldn't actually be aware of without having the visualization. And that's, again, saving us time and money, especially every single one of you knows how much only 1 day of delay in the turnaround costs. Not only talk about manpower, but also of basically loss of revenue because we can't produce. And this is just one of the steps we can take in the whole story, basically saving us time and extra cost by planning ahead and making the planning go more smoothly. Pretty sure there's a whole bunch of use cases that I haven't mentioned yet here. Probably even more that I wouldn't even think of. I know that the challenges, there's a lot of common challenges, but there's also a lot of individual challenges. So if you want to go further into the detail, feel free to contact us and have a session together, look at what improvement UPV can bring to you. This goes for new customers as well as for existing customers. And I think we'll pretty much find a good solution with UPV that will make life easier for you.